A loss under a liability policy is modeled by an exponential distribution. The insurance company will cover the amount of loss in excess of a deductible of 2000. The probability that the reimbursement is less than 6,000 given that the loss exceeds the deductible is 0.5. Calculate the probability that the reimbursement is greater than 3,000 but less than 9,000 given that loss exceeds deductible. So a very important variable here is reimbursement given that the loss exceeds deductible, because that appears in what they are asking and that also appears in the given condition. Reimbursement is less than 6,000 given loss exceeds deductible. So now the good news is that exponential distribution is memoryless, and therefore the variable that loss the reimbursement variable given that the loss exceeds deductible is exactly distributed in the same way as the loss. Therefore, reimbursement given loss is so if y is the reimbursement given that loss is in excess of deductible and x is the loss, then by the memoryless property y has the same distribution as x, and we have to find probability that y is between 3,000 and 9,000. So since in everything, whether it's what we have to find or whether what's given, we are talking about reimbursement given losses in excess of deductible. Therefore, we just treat that as the variable. The reimbursement given loss is in excess of deductible as the variable y, and y has the same distribution as x. So it means y is also exponential. So g of y would be 1 minus e to the negative ky. And we are given that g of 6,000 is 0.5 because probability that reimbursement is less than 6,000 given that loss exceeds deductible means probability y is less than 6,000. Maybe we can even make a note of it. Okay. And so we substitute 6,000 for y, so 1 minus e negative 6,000 k equals 0.5. That's what this probability is given to be. And so from here, e to the negative 6,000 k equals 0.5. Now, normally in a situation like this, we would find the k and then use that k to find what we are looking for. But here, since we're talking about this is what we have to find, the numbers involved are 3,000 and 9,000. And from 6,000, if we take square root of both sides, we get e to the negative 3,000 on the negative 3,000 k on the left, because square root means power 1/2. You take the power 1/2 of this, you get negative 3,000 k. And we take the square root of 0.5, which is 0.707. And now the advantage of just calculating e to the negative 3,000 k is that when you want to find this probability that y is between 3,000 and 9,000, that's g of 9,000 minus g of 3,000, and that will be 1 minus e to the negative 9,000 k minus 1 minus e to the negative 3,000 k. The ones will cancel out and it will be just e to the negative 3,000 k minus e to the negative 9,000 k. So now we notice that we can directly substitute the 0.707 for the e to the negative 3,000 k, and the e to the negative 9,000 k is the cube of e to the negative 3,000 k. So that would just be 0.707 cube, and the final result will be 0.35. Maybe we can even do this step here. Minus e to the negative 3000K whole cube. Okay, so this is 0.707 minus 0.707 whole cube, 0.35. That's choice B. And that ends this course. All the P problems are now complete.